Hello and welcome, my wonderful student, learners, and viewers at home. My name is Mr. Philip Maman. On your chemistry lesson today, we'll be looking at thermodynamic. Under thermodynamic, we'll be looking at energy changes in a chemical reaction. I'm sure you have followed some of my lessons previously. If you have issues you want to raise with me, you can get me on my number 08026598861. Again, 08026598861. Today we'll be proceeding to look at what is energy changes in a chemical reaction. I'm sure you're set with your pens and papers and you have sat down very attentively to pay attention to today's lesson. When chemical reactions occur, chemical reactions are the same as chemical changes. Old bonds are broken in the reactants and new bonds are formed in the product. These processes are accompanied by energy implication, either by absorption of energy or by evolving or liberating or giving up of energy. The energy requirement that accompanies chemical reactions are based on the law of thermodynamics. Now, the thermodynamics have two laws, but today we'll be looking at the first law of thermodynamics. The first law of thermodynamics states that energy can neither be created nor destroyed, but it can be transformed from one form to another. Little wonder, chemical energy can be transformed into electric energy. Heat energy can be transformed in electric energy can be transformed into energy, heat energy, and so on and so forth. Now, this can be used to classify reactions into endothermic reaction and exothermic reaction. Our emphasis on today's lesson is going to be on endothermic and exothermic reaction. What is endothermic and exothermic reaction? Like the name implies, endo means inside and exo means outside. So when you say endothermic, you mean heat inside. When you say exothermic, you mean heat outside. Follow me as we'll be defining what endothermic reaction and exothermic reaction is. Now, let me start with endothermic reaction. What is endothermic reaction? Endothermic reaction is a reaction in which energy in form of heat is absorbed from the surrounding. It leads to the fall in the temperature of the system and correspond to a gain of heat energy by the reactant from the surrounding. Example of endothermic reactions include the solution of crystals of ammonium chloride in water, the solution of sodium ethanoate in water, the solution of potassium trioxonitrate 5 in water, just to mention but a few. But I'd like to draw our attention to a very interesting reaction in chemistry. We call it extreme endothermic reaction. Usually very, very interesting. If you get barium hydroxide and mix it in a test tube or in a conical flask with ammonium chloride, then get a wet tissue paper and put it beneath and place the conical flask on top of the wet tissue paper. Then stir the mixture thoroughly. There will be a cold sensation that will come out from that reaction and might lead to the formation of ice on the tissue. Very interesting aspect of chemistry. So endothermic reaction is usually accompanied by a cold sensation in the vessel or the system or the reaction container that you are using. Now, endothermic reaction, the enthalpy change of an endothermic reaction is usually positive. What is enthalpy change? Enthalpy change means heat content of a system. Enthalpy means heat content of a system. So to calculate the enthalpy change for an endothermic reaction, usually you use the formula enthalpy change is equals to enthalpy of product minus enthalpy of reactant. Now we proceed to look at the reaction coordinate or reaction pathway of an endothermic reaction. We look at this reaction coordinate or reaction pathway of an endothermic reaction. Now, when you are drawing a reaction coordinate or reaction pathway, it's important that you note the two axes. Very, very important. We have the energy in kilojoules per mole, in this case, potential energy in kilojoule per mole. Then we have the reaction pathway. Now, another thing you must take note of is the shape of curve. As you can see here, the reactant is at the lower as down, and the product is high up there. So you find out that their delta H, which is the same as enthalpy change, is heat of product minus heat of reactant. When you do that, you get a positive value. And that's why we say that the enthalpy change for an endothermic reaction is usually positive. I'm sure you should be able to draw a reaction coordinate for an endothermic reaction haven't seen this clearly. Now let's look at the other aspect of today's lesson, which is exothermic reaction. Now I'm sure that oftentimes when you want to wash your clothes with detergent, sometimes you put the detergent on your palm and you feel a hot sensation. That hot sensation is as a result of energy in form of heat that is being liberated by the reaction between the detergent and your water. So let's define what exothermic reaction is. Exothermic reaction is a reaction in which heat is evolved, liberated, or given up to the surrounding. It leads to the raise in the temperature of the system and corresponds to a loss of heat by the reactant to the surrounding. Now, this exothermic reaction is usually accompanied by a hot sensation on the reaction vessel or container in which the reaction is taking place in. Example of exothermic reaction is addition of concentrated acid to water, dissolution of sodium hydroxide or potassium hydroxide or calcium oxide in water, and of course neutralization reaction, just to mention but a few. In this case, the enthalpy change for exothermic reaction is usually negative. Let me say again, the enthalpy change for an exothermic reaction is usually negative. Now, why is the enthalpy change for an exothermic reaction usually negative? The simple reason is because the reactant energy is higher than that of the product. And we say that enthalpy change is heat of product minus heat of reactant. So if you apply this formula, you get a negative value. I'm sure you must have understood this concept properly by now. So remember that the enthalpy change for an exothermic reaction is usually negative. Remember also that when you're plotting or you're drawing your reaction coordinate for an exothermic reaction, you must remember your potential energy in kilojoules per mole and your reaction pathway on both axes. And of course, also you must remember the shape of core. As you can see, activation energy, activated complex. Now, what is activation energy? Activation energy is the minimum energy that is required for a chemical reaction to take place. Again, activation energy is the minimum energy required for a chemical reaction to take place. Now, what about activated complex? Activated complex is the maximum energy required for a reaction to proceed. In other words, activated complex is the barrier that the reactant must overcome to become a product. My wonderful student, I'm sure you're enjoying this lesson already, but let me give you a quick illustration of exothermic and endothermic reaction. In this diagram, you see the vessel they are liberating, evolving, or giving off heat energy. In the second vessel, you see the container attracting, absorbing, or gaining heat energy. Now, this is exothermic and endothermic reaction in pictures. I'm sure my students have learned better now. Now, sometimes you apply a catalyst to a chemical reaction, and what the catalyst does is to lower the activation energy for a reaction. And that is why we have a reaction coordinate or a reaction profile for a catalyzed endothermic reaction. The dotted lines you see below here are the pathway, or is the pathway that the reaction take when a catalyst is applied. You can see that the activation energy is lower than it was when a catalyst was not applied. So you can see you have catalyzed activation energy, you have catalyzed activated complex, and so on and so forth. Sometimes in an examination, you'll be asked to draw a reaction coordinate or a reaction profile for a catalyzed exothermic or endothermic reaction. When it happens, this will come handy. I'm sure you have a glimpse at also the reaction profile or reaction coordinate for a catalyzed exothermic reaction. As you can see, the green dotted lines there shows that the activation energy is lowered by the application of a catalyst. So you can see the catalyzed activation energy and the catalyzed activated complex. My wonderful student, I have mentioned catalyst quite a number of times in my discussion today. I'm sure already some of you are asking, what is this catalyst? Yes, a catalyst is a chemical substance that alters the rate of chemical reaction, and the catalyst remain chemically unchanged during and after the reaction. A catalyst is not consumed during the chemical reaction. That's the meaning of remain chemically unchanged during and after the chemical reaction. I'm sure you must have come across several catalysts in chemistry, but remember that the catalysts have characteristics. One of the characteristics of a catalyst is that the catalyst is specific in nature. That means there's a specific catalyst for a specific reaction. Another one is that catalyst does not affect the equilibrium position of a reaction. It only affects the activation energy. Now, there are so many other examples of catalysts. I'm sure when you lay your hands on authorities, you'll be able to get more tips on this catalyst of the substance. Now, before you go, I would like you to look at my assignment today, my activity and exercise for today. I'm sure when you do that, you will be able to measure whether you have learned or not. I'll be waiting for your feedback on my WhatsApp as you have my number already. What exercise are you doing for me? Number one says define endothermic and exothermic reaction. Number two, draw a reaction coordinate for a catalyzed exothermic reaction. Number three, give two examples each of an endothermic and exothermic reaction. Number four, define a catalyst. And finally, number five, state five characteristics of a catalyst. I'm sure you did enjoy my lesson today. Join me some other time when I come your way with another series of lessons. But remember that you can always get my lessons on YouTube. Just go to YouTube and type Philip Mama. Then you have variety of lessons to listen to. If you like any of the lessons, you can subscribe my channel by just hitting the red button there written subscription, and you will subscribe my channel and you'll be informed anytime there's a new video on YouTube by Mr. Philip Mama. Thank you as you sit back at home and enjoy yourself. Have a blessed day. Keep learning. Chemistry is fun. Learning is fun. See you sometime someday as I come away again. Thank you very much.